Hello viewers, this is intro video to tutorial 4. In this video, I have clearly explained how to calculate the axial load in a column. Axial load means the vertical axial load only. This video does not explain anything about the moment in the column. The calculation of moment in the column, we shall do these calculations in the next video or next to the next video. The viewers who are interested in knowing the previous videos, they can scroll up my video channels and you can see my tutorial 1, 2, 3, etc. where I have clearly explained the load coming to each beam and conversion of the beam of the load into uniformly distributed load UDL, and the calculation of bending moment, maximum bending moment in the beam, and the shear force, working shear force in the beam, and the load, and the same is the load transferred to the adjacent near the column. Those things I already explained in previous videos. Viewers who find this video helpful to their design, please like it, share it to your friends in engineering side, architect side, or even students also. Come into the video, it continues. For the first row of column, the end load, axial load is 81.36 and the middle load is 156.83 kilonewton. For this frame only, I have made a drawing like this. This load is 156.8. This is 156.8 from the first floor, 156.8 from the second floor, the same from third floor. Okay, what about ground floor? The ground floor, there is no slab here. The load from slab is taken as 0 and the load of wall and the self height of the plinth beam or grade beam only would be there as a load for the ground floor. As well as for the roof slab, there is no wall in the roof slab. Above this is terrace floor, there is no wall in the terrace floor. Only the parapet wall will be there only for a height of 1 meter or 1.2 meter. This is very negligible. So wall load, there is no wall load here, but self height of the beam and slab weight will be there. The live load is in the terrace floor is also taken as only 150 kg per m square, which is approximately 50% of the live load we have considered in the other floors. So for making the calculation easy, I have made that taken as the load in terrace floor. So this is 1 floor load, 2 floor load, 3 floor load, 3.5 floor load. This is 4 floor loads. This is 4-storied building. So you multiply the load of 1 floor into 4. That will be the load here. That is 156.83 into 4 equal to 156.83 into 4 equal to 627.32 kilonewton is the load given by the all floor slabs including wall weight to the column. Now we are coming to this assumption and the worked out calculation based on assumptions. There we have calculated that load of column or self weight of the column is 330 kg or 3.3 kilonewton per 1 meter. So coming to here, we should include the self weight of the column. The self weight of the column we should include. That we have taken as 3 meter is the length of one ceiling height and 0.15 is the slab height. So 3.35 will be the height of column per 1 floor. 3.15 into 4 is the height from this level to this level. Plus this is 1.2 meter. Plus 1.2 meter. This is height from here to there. Then the basement height is, we have taken it as points plus 0.6 plus this height is 2.4. So total height is 16.8 meter is the total height of column from foundation to parapet wall top. So assuming this as the column, we have already seen that unit 1 meter weight of a column is into 3.3. This is equal to 55.44. Add this column weight 55.44. So 682.76 kilonewton is the axial load of this column, central column. This is a drawing which indicates the axial load of the column, including loads from all the floors in and the self height of the column. I have written on near to every column position. So please check that in the previous drawing we worked out as 682.76, that I have grounded 682.76. Similarly, I have worked out all these things. Okay, now we should decide whether this axial load alone is enough to design the column. That is not correct. For example, for these columns, this column 1, 2, 3, 4, for these 4 columns, the load, axial load itself is enough because the column is coming at the center point and there will be no moment in this column. You see in this drawing also, if you take this, the beam goes from here, so this moment equalizes this moment, and so this this load and this load, axial load of these things is enough to decide this footing or this column. So finding the eccentricity or the bending moment in the column we shall take in some other next tutorial. This is the final drawing or column layout which indicates the maximum axial load, including the loads of every floors and self weight of the column. So with this column axial load only, we cannot design the columns because the columns do have some moments in it. Supposing if this is a drawing of elevation, a pictorial drawing, this is these 3 are foundations, these are the columns, this human are standing there, these are the slab beams. So due to this application of load, the columns has a tendency to buckle a little on the sides. In this also you can see this same thing. So if a buckling or bending in the column comes up, there must be some bending in that column. So now we have calculated on the axial load. So how to calculate the bending or bending moment in the column? For that we have 3 options. One, we can calculate the bending by using that cantilever method. Cantilever method. 2, moment distribution method. 3, empirical method of finding the equivalent direct load which equalizes the bending. So this one is a very old method. So following this method will not give a good result. That will be more uneconomical. The size of the column will become too heavy and the number of rods required to be used will be heavy also. And also this method cannot give a proper design for the foundation design. So we need not worry about this. We can use this method or we can use this method. This is a very easy method in calculating the moment in the column, but this will not be so accurate. Very easy method. That moment calculated with the use of cantilever method will be a little higher, and that also will not be so economical. However, we can use this also. The moment distribution method is the correct method, but it involves a cumbersome calculation. This calculation can be done with the use of computer in Excel sheet. That will be more easy if you get practiced in that also. We shall see this calculation of moment in the column in the forthcoming videos. Thank you.